Okay, this video will be on lesson 6.2, describing functions. In this video, we will identify functions using sets of ordered pairs, tables, and graphs. We won't really talk about mappings in this video. We will also identify examples of proportional and non-proportional functions that arise in mathematical and real-world situations. Alright, if the graph of a relationship is a line, the equation is a linear equation. If the graph of a linear equation passes through 0, 0, it is a proportional relationship. An equation of the form y equals mx plus b is a linear equation. Equations that cannot be written in this form are not linear equations. Let's look at the first equation we were given. Y equals 4 plus 3x. Remember, it needs to be in the form of y equals mx plus b. But if we look at this equation, it's actually in the form of y equals b plus mx. The only thing we have to do is switch those two terms, and when we do, we get that equation. So we know that this is a linear equation. Next, we're going to ask ourselves, is it proportional or non-proportional? Well, we know because of the plus b, meaning that if b is equal to anything other than 0, we know that it is a non-proportional relationship. And that's how we would describe that equation. It is linear, but it's also non-proportional because of the plus b. Let's move on to number 2. Y equals 5 times x. Remember, it needs to be in the form of y equals mx plus b. But in this case, our plus b is 0. Remember, anytime b is equal to 0, we just don't write it. We do know that we have a linear equation, and because of the plus b, or because it's in the form of y equals mx or y equals kx, we know that this is a proportional equation. Alright, number 3, x is equal to 7. So remember, it needs to be in the form of y equals mx plus b. If we look here, we were given an example of how you would represent this equation in that form. So let me explain it to you why this works. Let's say I replace y with the number 1. So I'm just going to go through and combine my like terms. Well, 0 times any number, 0 times 1, 2, whatever number, it's just going to be 0. And if I'm adding a number, if I'm subtracting 7 from a number and I need to get x by itself, then I would need to add, meaning I need to do the opposite operation. When I do this piece, I have x is equal to 7. This is where this comes from. So we know that this is a linear relationship or a linear equation. Is it proportional? Well, we know that if my x is equal to 7 and nothing else is there, that means all of my x values are going to be 7. That means that I would have the graph of a vertical line. And if it's a vertical line, I know that it's linear, but it is not proportional because it will not go through the origin. Okay, and the fourth one, y equals 3 times x squared plus 1. Remember, it has to be in the form of y equals mx plus 1. And the exponent on the x is actually 1. Anytime we have 1, anything, with 1 as an exponent, remember, it's just itself. So we just don't write that 1, but we always know that it's there. So because the x is squared, we know that this is non-linear. And for this lesson, this is what we're doing. We're going to be going through stating if it's linear, non-linear, proportional, non-proportional, and the reasons why. Okay, remember in the TEK I told you that we will be working with graphs in this lesson. So let's look at reviewing how to graph ordered pairs on a coordinate plane. To graph points, remember that the x would be first, and the x tells us if we need to go to the left or go to the right, followed by the y-axis, and the y-axis tells us if we should go up or down. We've been given a point M. We know that point M is located at 4, 2. So that means from the origin, we would go to the right 4 because it's positive, and then we would go up 2 because it's positive. We have point N, so point N, which is located at -3, -3. That means from the origin, we would go to the left 3, then down 3, and put our point. Remember to always put your point and to label it, especially if you've been given a label. Now we have an equation, and we've been told to graph the equation. So in order for us to graph the equation, the first thing we need to do is to make a table of ordered pairs. And that's why we're making a table, so we can get those ordered pairs. Remember, the first column is going to be our x-axis, our input. The second column will be our rule. The third column would be our y, or our output, meaning when we put the value in to our expression or equation, this is what we get out. And then finally, we will have our ordered pairs. So let's begin. We begin with -2. So -2 has already been put there for x. -2 plus a +4 gives us a +2. So that's what we get out when we put in -2. So that means our output or our answer is 2. The ordered pair would be -2, 2. Next we have the input value 0. 0 plus 4 is 4. We get out 4. And our ordered pair would be 0, 4. Next we have the number 2 plus 4 equals 6, which means our output or our answer was 6. And the ordered pair would be 2, what we put in, and 6, which is what we got out. Then we have 6 plus 4, which is equal to 10. So when we put in 6, meaning replace x with 6, we got 10 for our answer. And our ordered pair would be, if we put in 6, we get out 10. And then we have 8 plus 4, which is 12. So if we put in 8 for x, we get out 12. Now we can go through and graph these. So I'm going to begin with -2, 2. -2, remember, means from the origin I will go to the left 2, then positive y means I go up, and I will put my point. Then I have 0, 4. 0 means I do not go to the left nor to the right on the x, but I will move up to the 4 and put my point. Next I have 2, 6, which means I go to the right 2, then up to the number 6 and put my point. Then I have 6, 10, which means I go to the right to the number 6, then I move up to the number 10 and put my point. Then I have 8, 12, which means I move to the right 8, move up to the number 12 and put my point. Now I'm going to connect my line. Well, I didn't do a good job of connecting my line, but hopefully you do a better job than me. I'm going to put arrows on both ends because we could have went either direction. We can take the table backwards, and we can also extend the table. Now that we graphed it, we're going to describe the relationship that we see. We know that we have a linear relationship because we have a straight line. We would have to say that it's non-proportional. And it's non-proportional because it doesn't go through the origin. But we also knew from our equation that it would be non-proportional because of that plus b. Next, we've been given 3 functions, and we're asked to describe each function. We need to write linear, proportional, or nonlinear. So looking at number 1, we have a straight line, which means that it is linear. It goes through the origin, so it is proportional. And that would be our description for number 1. Moving on to number 2, we have an equation, and we're again being asked to write linear, proportional, or nonlinear. So I know for it to be linear or proportional as well, linear and proportional, it would have to be in the form of y equals mx for it to be proportional. Well, I have y equals mx plus b, so for that reason, I know that it is linear, but I can state also that it's non-proportional. And let's look at the last one. Number 3, when I look at this line, it's a U-shaped. For that reason, I know that it's not a straight line, and I'm being asked to write linear, proportional, or nonlinear. This would be nonlinear because the graph is not a straight line, it is a U-shaped. And we're going to end the video with a real world situation. Vance charges $20 an hour to plow the snow off of driveways. The equation y equals 20 times x gives the cost y in dollars for x hours. State whether the relationship between the time and the cost is proportional or non-proportional. Then graph the function. We've been given an equation. The equation is y equals 20 times x. Again, we've been asked to state whether the relationship between the time and the cost is proportional or non-proportional. Well, if I'm talking about proportional relationships and an equation, I know that it must be in the form of y equals mx. Well, if I look at this, it is in that form, so I know that this relationship is going to be proportional. Finally, it tells us to graph the function. In order for us to graph this function, remember we need to create a table. And we're creating the table so that we can get our ordered pairs. I have the x, and remember x represents my hours. Then I have an equation, 20 times x. Once I work this out, I'm going to get my y. Remember y is the cost. And we're going to add one more piece to our table now. And this will be our ordered pairs. Now, I can start with the number 0. And the reason why is because this is a real world situation. And we can always begin with the number 0. So I'm going to put in the number 0 for x. So 20 times 0. Gives me 0. I could, or Vance could work 1 hour, so 20 times 1 would be 20. He could work 2 hours, so 20 times 2 is 40, and he could work 3 hours, so 20 times 3 is 60. We're going to stop there. So let's write our ordered pairs. I know for 0 hours, we have $0. For 1 hour, we have $20. For 2 hours, we have $40. And for 3 hours, we have $60. We have our order pairs. Now we can create our graph. So I have my X, I have my Y. Remember, on the X we have hours, and on the Y we have cost. We have 1 hour, 2 hour, 3 hour, and we put an arrow because we could keep on going. He may decide to work for 12 hours, but you only just need to choose about 4 values to replace for the variable when you are creating your own, so that you can see the relationship, just enough to see the relationship. So I have 1, 2, 3. Then I have the cost, $20, $40, $60. And again, put an arrow to indicate that the Y continues on. Then I'm going to graph my points. I know if he chose not to work at all, he has 0 money for 0 hours. If he worked 1 hour, he would have $20. If he worked 2 hours, he would have $40. If he worked 3 hours, he would have $60. Then just connect your points. And this is a straight line. I know mine looks a little crooked, but it is straight. Would I go back the opposite direction? No. I wouldn't put an arrow going the opposite direction because this is a real world situation and he's not going to make any money for negative hours. Okay, so a graph in a table can tell you quite a bit. We know that it is proportional because it does go through the origin. We can see that from the table, and we could also see it from the graph. And so for lesson 6.2, that is all you're going to be doing. You will be saying if it is proportional, non-proportional, linear, non-linear, and the reasons why. Have a great day.